Assalamualaikum and a very good day to panel of examiners. I, Imran Hakim bin Azhan from Group AS2467B, today would like to make a presentation on the final year project entitled The Utilization of Mango Seed Kernel Powder into Cookies as a Potential New Product from Fruit Waste and its Physicochemical Properties. Fruit, or better known as Mangifera indica al, is the famous tropical fruit that is originated from South Asia countries such as India, as well as countries from Southeastern Asia. According to Oliver Simakas et al. 2021, the trade for mango fruit, as stated from the Food and Agriculture Organization of the United Nations FAO, is extremely high, which accounted for 2 million tons, as well as the exportation of the fruit, thus subsequently making mangoes to be one of the most known tropical fruits to be consumed worldwide. However, it was reported that the wastage of mango seeds and peels reached up to 75,000 metric tons worldwide, which comprises about 7.5 million kilograms. Oliver stated that the mango byproducts such as its peel and kernel actually consist of many natural sources of valuable compounds, in which interestingly the nutrients coming from the waste components are actually higher than the nutritional values from the edible flesh. Now, moving on to the problem statement of this research. Here, about 7.5 million kilograms of waste coming from the combination of the mango peels and seeds, which leads to the abundance of waste and thus can potentially lead to various sorts of environmental problems, as stated by Oliver Simakas et al. 2021. Furthermore, the application of mango seed kernel powder into food product was successfully produced on products such as cakes, noodles, and biscuits, but less on cookies. Next, the method of addition of mango seed kernel powder rather than substitution of flour apparently has not yet been released or published for the production of cookies. This leads to the significance of this study, where we were able to distinguish the physical properties of mango seed kernel powder and physicochemical and sensory properties of mango seed kernel cookies from other mainstream cookies, as well as the potential to generate a brand new product and to minimize food wastage, since mango seed kernel are not being usually consumed, particularly in Malaysia. The objective of the study is to determine the physicochemical properties of butter cookies formulated with different percent of mango seed kernel powder, and the second objective is to determine the sensory qualities of butter cookies formulated with different percent of mango seed kernel powder. Moving on to literature review. Here, there are a few themes, where firstly is the physical and chemical composition of mango. Here, the mango fruit, or its scientific name Mangifera indica al, contains 3 different sections. The sections are epicarp, mesocarp, and endocarp. Here, the endocarp contains the seed and kernel of the mango, as stated by Lebaka et al. 2021. Next, for the components and composition of mango seed kernel, it is stated that mango seed kernel contains about 32 to 80% of carbohydrate, 4.92 to 13.16% of fat, 1.42 to 6.4% of protein. As for ash, fiber, and moisture content are 0.83 to 3.2%, 1.65 to 10.6%, and 9.6 to 9.89% respectively, as stated by Kitty Poon 2012, Lebaka et al. 2021, Masud et al. 2020, and Mutu et al. 2017. Moving on to the next theme, which is health benefits of mango seed kernel. Here, mango seed kernel contains a great amount of natural dietary fiber source, and from a bioactive point, it produces a lower glycemic index (GI), high balanced dietary fiber, as well as great number of antioxidants, as stated by Oliver Simakas et al. 2021. Moreover, the mango seed kernel have also been reported to have an anti-cancer properties, as stated by Lebaka 2021. Next, for the wastage and the various utilization of mango byproducts, the seeds and the peels of the mango, mainly from industrial processing, can potentially cause serious environmental issues, as stated by Mutu et al. 2017. Moreover, mango seed kernel has been applied as a sustainable packaging, edible film packaging, and active biopolymer, as stated by Oliver Simakas et al. 2021. Next, for the utilization of agricultural waste into cookies, few types of fruit byproducts, mainly its kernel, have been utilized aside from mango fruit. Examples are pomegranate, grapes, and apricot, as stated by Lau et al. 2021. A different study used jackfruit seeds and converted into flour, thus later made into cookies, as stated by Maske et al. 2020. Next, for the functional properties of mango seed kernel and its contribution to the quality of cookies, functional properties in general are defined as the intrinsic factors for the physicochemical properties of a food product. Therefore, it will reflect on the interaction between the food composition, structure, as well as its conformation, as stated by Chandra et al. 2015. For the last part of literature review on the cookie dough formulations and properties, here cookie dough is mainly comprised of 3 main components and ingredients, which are fat, sugar, and water, as stated by Panghal et al. 2018. To be specific, it is also stated that this quantity of the ingredients will be characterized and thus influence the final product of the baked cookies, as stated by Panghal et al. 2018. For methodology, there are 5 stages that involves in this research, starting from the first stage on the preparation of mango seed kernel powder, followed by stage 2, which was analysis of the powder, which were bulk density, water absorption capacity, and oil absorption capacity. Moving on to stage 3, where the cookies were produced with 3 different formulations and were baked at 30 minutes at 170 degrees Celsius. Next, stage 4 comprises of the physical-chemical analysis of the cookies, which happens to correlate with the first objective. Here, the analysis were hardness, color, water activity, fat, as well as protein content. Lastly, as according to the second objective, the sensory evaluation on the acceptance of the cookies by using 9-point hedonic scale were conducted. Now, moving on to the results and discussion. For the physical analysis of the powder, based from Table 1, bulk density of the samples obtained are as accordant to the study made by Das et al. 2019, and there is a significant difference at p less than 0.05. As for water absorption capacity, MSK has a lower value upon comparison with Das et al. 2019, while oil absorption capacity of the MSK is within range, and there is a significant difference for both water absorption capacity and the oil absorption capacity at p less than 0.05. The physical analysis on the cookies' hardness and water activity. Based from the Table 2, the hardness level of the cookies are lower than the theoretical value as stated by Panghal et al. 2018. Though, there is a significant difference for all 3 samples at p less than 0.05. As for the water activity, control and MSK cookies 4% are within range, but MSK cookies 8% is slightly lower than the expected range from the study made by Sari et al. 2014. And there is a significant difference for all 3 samples at p less than 0.05. Moving on to the color analysis of the cookies. Here, based on Table 3, both the top and the bottom parts of the cookies results were in line with the study made by Das et al. 2019 and Gumti et al. 2018, where there is a significant decrease in the L star and the B star value, while having a significant increase of the A star value. Moreover, the changes of the color was due to the flour color as well as Maillard reaction, as stated by Das et al. 2019 and Sari et al. 2014. The chemical analysis of the cookies. Based on Table 4, there is an increase of fat content in the cookies, and here the increase is as accordance to the study made by Das et al. From 2019 and Kaur and Bra from 2017, when their products they produced using the mango seed kernel has an increase of fat content. Moreover, there is a significant difference between the control and the MSK cookies at p less than 8% at p less than 0.05. As for the protein content, the results obtained contradict with the Das et al. Study from 2019. However, there is a significant difference for all 3 samples at p less than 0.05. Lastly, for the sensory evaluation analysis on the cookies, similar results were obtained for appearance and color based from the study made by Das et al. 2019, where there is a decrease of acceptance value. Moreover, there is no significant difference for the hardness, aftertaste, and overall acceptability. As for the taste, the results will contradict with Das et al. From 2019 and Gumti et al. 2018, since MSK cookies 4% has a higher acceptance than control. For the overall acceptability, there is no significant difference at p less than 0.05, though it can be said that MSK cookies 4% along with control has the highest acceptance value than mango seed kernel cookies of 8%. As the conclusion, mango seed kernel powder have high bulk density and water absorption capacity, but low oil absorption capacity value than wheat flour. Moreover, the addition of MSK powder has increased the hardness, water activity, as well as the fat and protein content of cookies. Next, for color analysis, lightness L star and yellowness B star of cookies top and bottom part decrease upon the addition of MSK powder, but increase in the redness of A star. And there is no significant difference for the hardness, aftertaste, and the overall acceptability of the cookies with different percent of MSK powder for sensory evaluation process. Lastly, formulation that contains 4% of MSK powder is suggested for the addition to be in cookies. For recommendation, it can be suggested that for further analysis on the carbohydrate, moisture, ash, and fiber on the addition of MSK powder into cookies can also be conducted for more detailed nutritional information. Furthermore, comparison of cookies with mainstream cookies in the market, particularly on the acceptance of addition of MSK powder in cookies, should also be conducted. Finally, a comparison between substituted and addition of MSK powder to determine which product has the highest acceptance and nutritional value should also be made. Now, for the next slide is the references, and that's all from me. Assalamualaikum. Thank you.